geometry students. This is 10.3. It's about applications of the Pythagorean theorem. So we're going to use the Pythagorean theorem in some situations. So here's the first example. What is the longest stick that can fit inside a 24-inch by 30-inch by 18-inch box? With all of these situations, it can be helpful to first draw a picture. So that's been done for you. There's this box here. It's 30 inches by 24 inches by 18 inches. Those are the three dimensions. Now, what might not be immediately obvious is that if you're trying to fit the longest stick possible in this box, it's actually going to be this diagonal that's drawn in as a dotted line and labeled X right here. Okay, that's how you could fit the longest stick. Now, in order to calculate that length, we first want to calculate this other distance, d. So it's this diagonal line across the bottom, but it stays on the bottom. So if we were doing that, take a look over here. D is the hypotenuse of this right triangle, and the legs are 24 and 30. So we could use the Pythagorean theorem, plug in 30 and 24 for the legs, and then the hypotenuse is D. 30 squared is 900, 24 squared is 576, and we still don't know what D squared is. D squared is this. So that's not the distance itself, that's the distance squared. Now that'll come in handy in a little bit. So now let's think about finding x. X is the hypotenuse of this other right triangle where the right angle is over here. One of the legs is D, and one of the legs is this 18 inches right here. So D squared, one of the legs, plus 18 squared, the other leg, squared, is equal to the hypotenuse squared, x squared. Now, we already know that d squared is equal to this. So let's plug that in for d squared. 18 squared is 324. If you add these together, you get 1800. And that's equal to x squared. Remember that if you want to find just x and you have x squared, you would square root both sides. So the square root of 1,800 is 42.4. And remember that this is a distance. Our units are given in inches, so this is in inches. The longest possible stick is about 42.4 inches. Okay, here's another example. The front and back walls of an A-frame cabin are isosceles triangles, each with a base measuring 10 meters. So I guess this base along the bottom here is 10 meters. And legs measuring 13 meters. So I guess each leg of this isosceles triangle, like this leg is 13 meters, this leg is 13 meters. The entire front wall is made of glass that's 1 centimeter thick, and that costs $120 per meter squared. So what did the glass for the front wall cost? Now, I redrew the triangle and put in some measurements to help. So the entire base is 10. If we're splitting this into two equal-sized right triangles, then this is, the base of just this right triangle is 5, and the base of this other right triangle is 5. Together, that's 10. We don't know the height yet, but we know that the legs are each 13. Okay, so what if we wanted to find the height? We could use the Pythagorean theorem. We know the hypotenuse. We know one of the legs. So plug in 5 for one of the legs. Plug in 13 for the hypotenuse. 5 squared is 25. 13 squared is 169. If we subtract 25 from both sides, we get that h squared is 144. If you have h squared and you want to know what just h is, you take the square root of both sides. And the square root of 144 is 12. So the height of this triangle or this triangular glass is 12 meters. So if we're then going to calculate the area of the glass, we can use the area for a triangle 1/2 the base times the height. That's the area formula for a triangle. The entire base is 10 meters, so plug in 10 for the base, and then 12 for the height. So 1/2 base times height, that's 60 meters squared being the units. Now they told us that for every meter squared, it costs $120. So $120 per meter squared, and we have 60 meters squared. So we multiply 120 and 60, and we get 7,200, but $7,200. Okay, and then finally, I just want to make sure that if you get 2 points on a grid, that you know how to use the Pythagorean theorem to find the distance between them. So it says find the length of each segment by using the segment as the hypotenuse of the right triangle. So basically you're going to draw in legs of this triangle and then use the Pythagorean theorem to find the hypotenuse. We could draw in our legs like this on this one. So if I go to the next screen, I tried to draw in dotted legs for this one, but they didn't show up that well. But anyway, one of the legs is 4 and one of them is 2. So if you plug those into the Pythagorean theorem as the legs, it looks like this. 2 squared is 4, 4 squared is 16. So I guess c squared is 20. If we square root both sides to find just c, c is the square root of 20, which is about 4.5 units. You could use a similar process to solve all of these. The only other one where I've shown the steps is D. So if you drew in the legs, like this leg and this leg, this horizontal leg would be 8 because there are 5 units before the y axis and then 3 more units after. So 8 units for that leg. And then how about this other vertical leg? 1, 2, 3, 4, 5, 6. So our other leg is 6. 8 squared is 64, 6 squared is 36. You add those together, you get 100. And that's what c squared is equal to. So just c is the square root of 100, which is 10. I don't need to go to 10.4. That'll be another video. Take your time as you watch this. You can replay things. That's the nice thing about videos. Your only homework for 10.3 is the exit ticket follow-up on Canvas. I might change the name to just be exit ticket because it's not a follow-up if we haven't done it once before. Good luck on that. Let me know if you have questions, and there will be more videos or another video for 10.4.